Okay guys, in this video we're going to continue to try to factor a polynomial completely, but specifically using division. And so there will be certain instances where our traditional factoring methods fail. And so something like number 18 here, this is some polynomial that if I were to try to factor this expression on the right here, there's no GCF and it doesn't really work with grouping. And so in that case we'd have to use division to our advantage. And so specifically we're going to be looking for things that are factors. Well, remember that a factor of something is something that divides into it evenly. So what I want to do on these exercises is to determine whether this binomial that I've given you here is indeed a factor of the given polynomial. And so all we're going to do is we're going to divide, but specifically checking for does it divide in evenly. And so for this here, we could use synthetic division. We could put in our coefficients, so 2, 5, negative 37, and negative 60 here. Try to get that a little bit of contrast there. And we're going to put x equals 4 out here. Remember that we would say whatever I'm dividing by, set that equal to 0. This is the actual x value that we put on the outside here. So as we drop down our lead coefficient here, we say 4 times 2 is 8. 8 plus 5 is 13. 4 times 13 is 52. 52 plus negative 37 is a positive 15, and 4 times 15 is a 60, which this is pretty cool here. A couple things I'm going to write. First one is that this is f of 4. In other words, when we plug 4 into our function here, we get a y value of 0, which is impressive because that means that x equals 4 is a solution to this equation. Remember, solutions are x values that when we plug them in cause our y value to be 0, and these are also known as x-intercepts. Long story short, what we see though is that this is also our remainder. And so if I were to write a conclusion here, I would say first of all what we got was, and sorry I just don't have a lot of room here on my canvas, we got 2x squared plus 13x plus 15 plus 0 over the thing we were dividing by, which is x minus 4. And 0 divided by anything is really just 0. So what we get is this 2x squared plus 13x plus 15, and because the remainder was 0, we would say that x minus 4 is a factor. And so that is something that you will want to list on your paper here. We can say that x minus 4 is a factor of f of x since it divides and leaves a remainder of 0. And that's really what we're looking for here. So I want to look at just really quickly one more with you here. If you care to see it, you can go ahead and try it on your own, but we want to divide this and see, do we get a remainder of 0? And so in this particular instance, let's switch over to blue. We would see that we have a 6x to the 5th, a negative 15x to the 4th, a negative 9x to the 3rd. But we have 0x's squared, 0x's to the 1st, 0 constants, and out on the outside this time we're putting a negative 3. So we're going to drop down our 6. We say 6 times negative 3 is negative 18. Negative 18 plus negative 15 is negative 33. And take that times a negative 3, we get a positive 99. Plus a negative 9 is really a positive 90 times a negative 3 is negative 270. Yikes. Plus 0 is negative 270. You can see that this is getting pretty big. We would say that here, I even got to pull up my calculator, negative 270 times a negative 3, I suppose would be, let's see, 270 times 3. That would be the same thing. Since they're both negative. 270 times 3 is 810. So we get 810, and we get an 810 here. We have to take that times a negative 3 times 3, that is negative. Negative 2430. So negative 2430, negative 2430. And we want to box this, and we also want to just make sure we mention this is f of negative 3. In essence, if we plug in negative 3 into our function here, we would get this impressive y value of negative 2,430. But the other thing we want to mention here is that this is our remainder. And so the thing to note about the remainder is that it wasn't 0. So in this case, we would say that, in particular, x plus 3 is not a factor of f of x, or in this case, I pay attention, g of x, since it divides it and doesn't leave a non-zero remainder. So this is what I want you guys to be checking for when it comes to checking for something being a factor or not. Cheers.